Okay, so with this particular strategy, it doesn't always work with really large numbers, not necessarily the quickest or fastest when in those situations, but it's pretty good when we're looking at single numbers and with double numbers or double numbers and double digits and double digits. So let's kind of take a look at what it's all about. So it's called the decomposition for division. We're taking the dividend and breaking it apart based on our understanding of the multiples of the divisor. So it does require that you have a good sense of your basics in terms of multiples of a number. So let's take an example. So let's take 4 and let's take the number 104. So our dividend is 104 and our divisor is 4. So instead of looking at it as 4 or 104 divided by 4, what I'm going to do is I'm going to take the 104 and I'm going to split it up. I know my 4 multiples of 4 fairly well, so I'm going to split it up into two things. I know that 104 can be divided into 100 and then 4, 100 plus 4. So what I ask of myself is how many times does 4 go into 100, or how many times can I divide 4 into 100? And I know that it's 25, because for me, that's an easy one. It's based on money, so I know there's 25, 50, 75, 100. I do the same thing for the 4, so 4 divided by 4. How many 4s are in 4? And I know that's 1. So then I ask myself, okay, I have a set of 25 and a set of 1. If I add them together, what do I get? I get 26. So it's quite simple when you have some simple numbers. So let's try something a little bit more complicated. So let's look at 32 divided by 167, or sorry, I should say that the other way, 167 divided by 32. So how many 32s are in 167? So what I'm going to do is, again, I'm going to take this number and I like to think of it as 30 and 2. Okay. Then I'm going to take this number and I'm going to use it and I'm going to think of it as 150 and 17. There's a reason I chose 150. The reason I chose 150 is because my 30, use a different color for this, 30 can be evenly divided into 150. I know there are 5 of them. How do I know there are 5? Well, 15 divided by 3 is 5, and then I have a 0, and we know this based on our base 10s when we did our multiplication and division of base 10s. So I know that if I divide 150 by 30, I'm going to get 5. The problem is that I'm trying to divide 167 by 32, not just 30. So I have to ask myself, how many more 2s do I have left over? Do I have enough in this 17? Well, I know I need 2 times 5 because I've done 35 times and now I need to do 2 5 times. So if I show you here, I did 30 and then 30 and then 30. Sorry, my computer's quite slow today. And then 30 and then 30, right? If we added these up, they would be 150. But it's not enough because remember, I'm trying to divide 130 or 32. So I need with each of these 30s to have a 2. So I'm going to put a 2 right beside each of these 30s and see what that would be. So 2 and 2 and 2, 1, 2, 3, 4, 5 2s, right? We had 5 30s, now we have 5 2s, and that ends up being 10. So what I know is that 32 can go into 150, or 30 goes into 155 times, but I also need to then give over 10 more. So now I know that 32 can go into 160. What am I left with? So I took 10 away from 17, so I'm left with 7. So what does that mean? Well, that means that 32 can go into 167 5 times with a remainder of 7. Let's verify this using our long division. So here we go. 32, divided by 167 divided by 32. I always say it wrong. So I know 32 can't go into 1, 32 can't go into 16, so I have to ask myself, how many times does 32 go into 167? So I'm going to try, if I tried 4, I know that I wouldn't be enough, so I'm going to try 5. 5 times 2 is 10, so 0, and then I carry my 1, and then I have 5 times 3, which gives me 15, plus 1 is 16. So I'm left with, if I subtract these, I'm left with 7, which doesn't go in, which means that's a remainder of 7. So I was correct. Now, why does this work? Well, what's really important is the relationship between division and multiplication. They are interrelated. They're opposite sides of the same coin. So I know that when I'm saying how many times does 30 go into 150, I'm also saying 30 times what gives me 150. I know 30 times 5 gives me 150. I know that 2 times 5 gives me 10. 10 plus 150 is 160. And what's left over, that's the 7. Okay, that's why it works. So it's based on this relationship between multiplication and division, understanding that multiplication is repeated addition. So that's why this type of decomposition for division works. But it is complicated in that you need to know your math facts pretty well.